Welcome all to today's maths class. So today we are going to learn chapter 3. Chapter name is Arithmetic Progression. As the name indicates, we are going to learn about arithmetic progression or APs in this chapter. Before knowing what is an arithmetic progression, we have to know what is sequence. Since arithmetic progression is also a sequence. So what is a sequence? Sequence is just a set of numbers which have a definite order, or which a list of numbers which follow a definite pattern. You can see an example of A1, A2, A3, A3, A4 and AN. A set of numbers where the numbers are arranged in a definite order. Means all the numbers in the set must have a definite order. They cannot be placed anywhere else. They should follow a definite order. Like we can take the example of natural numbers is called a sequence. This is a list of natural numbers starting from 1, 2, 3, 4, 5. The list goes on. The dot means the list goes on forever. These dots on are called ellipses. See, this is an example of sequence since they are placed in a definite order one after the another, and every number differ from the previous by one. You can see here 1 increases, here 1 increases, 1 increases and 1 increases. That is, 1 is increased into every other term in this sequence, and it follows a definite order. Let's see another sequence which increases by 5, increments by 5. See, you can see that every number differs from the previous number. 5 increases to the next term. You can see 5 increases in all the terms, and the sequence goes on forever. So you have seen two patterns of numbers. These two are examples of sequence. First one is a natural numbers. 1 increases to every next term in the first sequence, and 5 increases in the second sequence. 5 increases to the every next term in the sequence. It goes on like 25, 30, 35, 40. It goes on like forever. You can see this 1, 2, 3, 4, 5 are called the terms of this sequence of natural numbers, and in the second one 0, 0, 5, 0, 5, 10, 15, these are called terms of this sequence. So now we are going to see what is a term. What do you mean by terms in a sequence? In a sequence, ordered terms are represented as T1, T2, T3, etc. Tn. In general, the sequence can be written as Tn. Like, see, in general form of the representation of terms in a sequence is Tn, and every single term is written as T1, T2, T3, etc. Tn. So this is the ordered terms can be represented like this in every sequence can be represented in a general form, that is Tn. You can see here, and every first term, second term and third term, etc. goes on. So the terms in a sequence can be represented as T1, T2, T3, etc. So if a sequence is infinite, for every positive number n we will have a term called Tn. For every positive number n we have term, means for all the positive number till infinity we will have a term Tn. Now we are going to do an activity. Some sequences are given below. Show the position of the terms by T1, T2, T3, etc. So first question is solved here. The sequence is 9, 15, 21, 27. So we have to just write in the place T1 is equal to the first term, T2 is equal to the second term, and like this. So the question is 9, 15, 21 and 27. We have to show the positions of the terms of this sequence. That is, we have to write it using like this T1 stands for the first term. So what is the first term here? 9. T2 second term. T3 third term. And here also T4 is also the T4 is equal to 27. So like this we are showing the positions of the terms. So the first question is here, and in the second question is this 7 comma 7 comma, it is a sequence of 7, and we have to show the first term. T1 is 7, T2 is again 7, T3 will also be 7. And the third question is -2, -6, -10 and -14. We have to find the T1. The first term of the sequence is -2, T2 second term is -6, and T3 third term is -10. So we have find the terms of positions of terms of the sequence. Some sequences are given below. Check whether there is any rule among the terms. So here some sequences are given. We have to check whether we have to check there is any rule among, that is any how the sequences are related, the terms in the sequences are related to each other, and find the similarity between two sequences. And we have to check whether there is a similarity between these sequences. First we have to check the similarity between terms of a sequence. So it is represented in this form. So let's do that. So it is represented in this form, that is first sequence. You can see the first sequence was 1, 4, 7, 10 and 13. So it is represented in this form, that is 1. The difference between 1 and 4 is, 4 minus 1 is 3. So when 3 is added to the first term we get 4. 1 plus 3 is 4. And also the next term is 7. So what is the difference between 7 and 4? When 3 is added to 4 we get 7. And the next term is 10. How we get 10? When 3 is added to 7, 7 plus 3 is 10, and 10 plus 3 will be 13. So we can write 13 here. 13, and 13 plus 3 will be 16 here. That is 13 plus 3. So 3 is added to all these terms. See, you can see 1 plus 3, 4 plus 3, 7, 7 plus 3, 10, 10 plus 3, 13. So 3 is the increment or the increase in each term in the sequence. So we have filled the boxes. Go to the next question. The next question, the terms are 6, 12, 18, 24. So what is the difference between 12 and 6? 6, and 12 and 18 is again 6, and 24 and 18 is 6. That is 6 plus 6 is 12, 12 plus 6 18, 18 plus 6 24. So what will be the next? 24 plus 6, that will be 30. But what will be here? 30 plus 6, that will be 36. So 6 increases in this question. So go to the third question. Third question, the terms are 3, 3 and 3. So here what is the difference between 3 and 3? 3 plus 3 is 0. The difference between 3 minus 3 is 0. So 0 is added to all terms. 3 plus 0, 3, 3 plus 0, 3, 3 plus 0. So 0 increases. That means no increase in the terms. The terms are just repeating. So 0 is added to all the terms. So what will be the next term? 3 plus 0, 3 will be the next term. Here also 3. It continues like this. So 0 increases in this sequence. Go to the next question. The question is 4, 16, 64 goes on like this. Difference between 16 and 4. See, when 4 is multiplied with 4 we get 16. When 16 is multiplied with 4 we get 64, and it goes like this. So 4 increases in this question. So in this question 4, 16, 64, 4. So what will be here? Here will be 256. And what will be 256 into 4, and the term goes on like this. And in the last question, -1, minus 1.5, minus 2, minus 2.5, and it goes on. So what is the difference between first and second term? So first term minus 1 and minus 1.5. So when we subtract them, we get minus 0.5. So when 0.5 is added to minus 1 plus minus 0.5, we get minus 1.5. And again 1.5 is added to this term, we get minus 2. Again 1.5 added to this term, we get minus 2.5, and it goes on like this. So here the difference or the increase in the term is negative 0.05. So we can see that the increase in this term is 3, and in this question the term sequences increase by 6, and in this question it increases by 0 since the terms are repeating, and in this question it increases by 4. When 4 is, we have to multiply. We are not adding, we are multiplying 4. In the last question a negative number is increasing in each term, that is minus 0.5 is increasing in each term. So you can see that in the question 1, 2, the question 1, 2, 3, the numbers are added to the sequence. To get the next term, a constant number is added to every term, so that we get the next term. You can see that in the first question 3 is added to every term, so that we get the sequence, and in the second question 6 is added, third question 0 is added, and in the last question a negative number, that is negative 0.5 is added to each term to get the next term, the terms of the sequence. And in the fourth problem, number is multiplied, a constant number is multiplied to every term of the sequence, so that we get the we get the terms of the sequence, that is 4 into 4, 16 into 4. A 4 is multiplied to each term. So we can call the sequence 1, 2 and 3 as arithmetic progression. Since a constant number, particular number is added here to all the term to get the sequence, the next term of the sequence, these sequence, that is the first question, second question, 3 are examples of arithmetic progression. And this also, fifth question is also arithmetic progression. Since a negative number is added to get the next term, this is also a arithmetic progression. And the question number 4 is an example of geometric progression. Since a number is multiplied, since 4 is multiplied to each term of this sequence to get the next term, the question number 4, that is 4, 16, 64 is an example of geometric progression. So let us see what is the definition of arithmetic progression and geometric progression. Arithmetic progression, the next term is obtained by adding a particular number to the previous term. You can see 3 is added to 1, we get the next term. Here 3 is added to 4, we get the next term. 3 is added to 7, 3 is added to 7, we get the next term. And in this also 6 is added, with 6 we get the next term. 6 is added to this previous term, we get the next term. 6 is added to 18, so we get the next term. So these are the examples of arithmetic progression. So let's see what is geometric progression. In this sequence, next term is obtained by multiplying previous term by a particular number. You can see previous term is multiplied by particular number. In this GP you can see previous number is term is 4. 4 is multiplied 4, we get the next term 16. 16 again multiplied with 4, we get the next term 64. 64 multiplied with 4, we get the next term 256, and it goes like this. So this is an example. 6, 4, 16, 64 is an example of GP, and the rest are examples of AP. Here 3 sequences are given. So in the first sequence is 100, 70, 40, 10, minus 20, it goes on like this. So in the first question, the first term is 100, second term is 70. So what is the increase in this sequence? 100 and 70. To get that, what we will do, 70 minus 100. What is the difference? Minus 30. So when minus 30 is added with 100, we get the next term, the second term, as 70. When again minus 30 added to 70, we get the third term, that is 40. So a constant number is added to the previous term to get the next term in the sequence. And in the second question also, minus 7 and minus 4, minus 1, minus 2. So we get the difference. What we will do, minus 4 minus minus 7, so it will be plus 3. That is, when we add 3 to minus 7, we get the next term, that is minus 4. Again 3 is added to minus 4 to get the next term, that is minus 1. So a constant term is added to every term of the sequence to get the next term. And in the last question, it is the repetition. Terms are repeating, that means it is not adding any number to get the next term. So we will write it as 4 plus 0, 4 plus 0. 0 is added to every number since the numbers terms are repeating. So in all these sequences, 3 sequences, a constant number is added to the previous term to get the next term. These constant numbers, see, in this case minus 30, in this case 3 and 0, these constant numbers are called the common difference. Common difference is a next term. The constant term that is added to every term to get the next term of a sequence, previous term to get the next term, is called the common difference. So let's see what is. In the each of the sequences, every term is obtained by adding a particular number to the previous term. The difference between two consecutive terms, so you can see the difference between two consecutive terms is constant. It's not changing. A constant term is added. So here also a constant term is not in a particular sequence, particular number, common difference will be there. See, and see, if the difference between two consecutive terms is constant, then it is called the common difference, generally denoted by the letter D.